Hello everyone, welcome to PUC Physics Explained channel. In the sixth session of the PUC First Year Physics, Chapter 1, Units and Measurements, I am going to take the part 1.5, Dimensional Formulae and Dimensional Equations. In the previous session, I have taken the dimensions of the physical quantities. There we have discussed the dimensions of the fundamental or base quantities and how those are used to represent the dimensions of the derived or other physical quantities. Here, we'll take the dimensional formulae and dimensional equations for all the physical quantities. Kindly subscribe to PUC Physics Explained channel. If you have subscribed, kindly share and comment. Here I am going to provide the ready reference material along with the explanation in the PowerPoint presentation. You can refer and you can use that. The first will take the dimensional formulae and dimensional equations. The expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called dimensional formula. Here the expression, which shows how and which of the base quantities represent dimensions of any physical quantity, that is a derived physical quantities, is called the dimensional formula of that given physical quantity. For example, the dimensional formula of the volume is within the square bracket m to the power 0, l to the power 3, t to the power 0. Here volume consists of the three lengths only, and that's why the three powers of the L we have taken, and m is having the 0 power and t is also having the 0 power. And that of speed or velocity is the speed is the displacement per unit time, and that's why it is not having any mass. Therefore, the mass having the power 0 and L length having the power 1 and t to the power of minus 1 is in the square bracket if you represent, that is the dimensional formula of velocity. Similarly, within the square bracket m to the power 0, L to the power 1, t to the power minus 2 is the dimensional formula of acceleration, that is the length per time square. That is a displacement per time square, we know that. Then within the square bracket m to the power 1, L to the power minus 3 and t to the power 0, which gives the dimensional formula of the mass density. Mass is the mass per volume. Like this we can represent the dimensional formula for the some physical quantities. And now we can say that an equation obtained by equating physical quantity with its dimensional formula is called dimensional equation of that physical quantity. Here the dimensional formula what we have taken for the different physical quantities. If we equate this one with the physical quantity, the physical quantity symbol what we are going to take, if we equate that and that equation what we are going to have, that equation is called as a dimensional equation. Further moving, thus the dimensional equations are equations which represent dimensions of physical quantity. The dimensional equations are the equations which represent dimensions of physical quantity in terms of base quantities. Whatever the dimensions we are going to use for the representation of the dimensions of physical quantity, those will be in terms of the base quantities. The dimensional equations of volume phi, speed phi, force F and mass density rho may be expressed. Again, we will be express the dimension equations here. For the volume we will take first, that is the phi, and which is the three lengths, that is the length, breadth and width we can take, then that will give the volume, and both are, all the three are lengths only, therefore those will be multiplied lengths, then L raised to L 3 or L to the power 3 we are going to take. Then this volume V is equated with the dimensional formula of volume, that is m to the power 0, L to the power 3 and T to the power 0. Here mass is having 0 power and time is also having the 0 power, but the length is having the 3 powers. As we know that it is L raised to 3. This is the dimensional equation of the volume. Similarly, we will take for the velocity, that is a length per time, that is L per time, and that can be written as L T raised to minus 1. Then the velocity V within the square bracket is equated with the dimensions which are represented within the square bracket as m to the power 0, L to the power 1 and T to the power minus 1, and this equating what we take, that is the equation of the dimensional equation of velocity. Force, mass multiplied with the acceleration, mass multiplied with the length per time square, and that can be written as ml t raised to minus 2. Then the force F will be equated with the dimensions of that force, that is within square bracket m to the power 1, L to the power 1, T to the power minus 2, and this is the dimensional equation of the force. Similarly, we will take for the density, that is the mass per volume. The mass per unit volume, that is L cube, already we know. Then this density rho is equated with the dimensions of that density, that is m to the power 1, L to the power minus 3, T to the power 0. This is the dimensional equation of that density. Similarly, here we will take the how we are going to establish the dimensional equations for the different quantities. The velocity, already we have taken the explanation of this one. The velocity equal to displacement per time. That is equal to L by T, and that can be written as L T raised to minus 1, and that equation can be written as V equal to within the square bracket m to the power 0, L to the power 1, T to the power minus 1. And acceleration, second one, acceleration equal to change in velocity per time, and that will be displacement per time, that is a velocity, and change in velocity is also represented as the displacement per time, and per time we are going to take, that is L bar T, and this can be written as L by T raised to 2, and this can be written as L T raised to minus 2. The dimensional equation is the acceleration A can be written as the dimensions of the acceleration, which are represented in square bracket m to the power 0, L to the power 1, T to the power minus 2. And similarly, we will take for the force. The force can be written as mass into acceleration. Then mass multiplied with the displacement per time square. Then mass multiplied with the L by T square. And this can be written as ml T raised to minus 2. Then dimensional equation for the force, that is in the square bracket of that symbol, the force, and that is equated with a in the square bracket m to the power 1, L to the power 1, T to the power minus 2. That is the dimensional equation of the force. The other physical quantities like the pressure, stress and modulus of elasticity, all three are having the same dimensional equations, the same dimensional formulas, and if you equate with that symbol of that particular physical quantity, dimensional equations we are going to get. And how those are developed, we'll see here. The pressure can be written as force per area. Then pressure equal to force per length into breadth. Then that can be written as the force will be given in the previous slide we have taken, that is a ml T raised to minus 2. Then length and breadth, again we'll take the two lengths, length and length, that the physical quantity we are going to get. Then the two lengths are there. If you take in the numerator, the one negative and one negative get cancels, one negative in the numerical will remains, that is an equation we are going to get m to the m L raised to minus 1, T raised to minus 2, and the dimensional equation we can write within the square bracket P, that physical quantity, and within the square bracket m to the power 1, T to the power, L to the power minus 1, T to the power minus 2. This is the dimensional equation of pressure. Then the stress is also given by the same formula. There is a force per area. Therefore, that is the same the dimensions it will have. The m to the power 1, L to the power minus 1, T to the power minus 2. Then that stress is equated with the dimensional formula of this stress, that is within the square bracket m to the power 1, L to the power minus 1, T to the power minus 2. Okay, here you can see this is the dimensional equation of the stress. Modulus of elasticity. The elasticity is given by stress by strain. The stress dimensional form equation already we got, and strain is unitless. The strain is given as the change in length to the original length. In the numerator also we are going to get the length, and denominator also we are going to get the length. There is a delta TL by L we are going to get. Therefore, that both are in terms of the length, those are unitless. Those are not having any dimensions here. Then elasticity is equal to stress it will becomes. The stress already we have taken, it's a force per area, and for that dimensions what are there? Those are m to the power 1, L to the power minus 1, T to the power minus 2. And that modulus of elasticity, m can be equated with these dimensions, that is within the square bracket, m to the power 1, L to the power minus 1, T to the power minus 2. This is the dimensional equation of the modulus of elasticity. We can see here all the three physical quantities, pressure, stress, and modulus of elasticity having the same physical quantity, same dimensional equations. Then the dimensional equation can be obtained from the equation representing the relation between the physical quantities. Here this dimensional equation what is there, which can be obtained by taking the relations between the physical quantities. That means already how we have the relations we have taken. That is the velocity we have taken the displacement per unit time. That is a L bar T. L is also a physical quantity and time is also a physical quantity, and the relation, that is the numerator and denominator relation it is having, and that relation the particular velocity is having with the other physical quantities. That relations we are going to represent in this one dimensional equations. The dimensional formulae of a large number and wide variety of physical quantities derived from the equations representing relations among other physical quantities. Okay, again the force per area, like that the relations, there are some other relations we are going to get for the large number or wide variety of physical quantities. And by taking those relations, we can express the dimensions and later the dimensional equations from that, and express in terms of the base quantities. And all those are the final, whatever the dimensional equations we are going to get, those are in the form of base quantities only, in terms of the base quantity, and which are given in the appendix 9 of the ready reference book from the NCERT. Okay, that we are going to take here. The appendix A9, the dimensional formula of physical quantities. And here the some 12 physical quantities are shown in the slide, and remaining physical quantities, those are available in the NCERT book for the ready references, and you can refer those. And those quantities also I am going to show in other sessions. In these 12 quantities, what are there? These physical quantities: area, volume, mass density, frequency, velocity or speed, acceleration, force, impulse, work, energy, power, momentum, pressure, stress, and the relationship with other physical quantities. Okay, to represent the dimensional formula. Those are length multiplied with the breadth, length, breadth, height, mass per volume. Okay, per unit time, period this one, displacement per time, velocity per time, mass into acceleration, force into time, force multiplied with distance, work per time, mass into velocity, force per area. And their dimensions, here it is written, the dimensions what are there, and their dimensional formula by considering all these three fundamental dimensions, those we are going to represent, those are the dimensional formula. in the mechanics, we are going to present these three main dimensions of the fundamental quantities, and the mass, length, and the time we are going to get, and from that the dimensional formula we are going to get commonly. And the higher order of the or a big numbers of these physical quantities, which variety of the physical quantities, dimensional formula will be having the other dimension of the other that base quantities also we are going to take. This is about the dimensional formula and dimensional equations of the physical or derived physical quantities, and all other physical quantities which are already developed, and those are represented in the appendix 9. You can refer those also. And I have taken the previously up to this part, the what are the parts are there, the explanation of those parts I have taken, and their links I have given in the description. You can refer and watch those videos also. Thanks for watching. If you like, share, subscribe, and comment.